In this section we're going to give the general definition of the trigonometric functions, and we're going to use the unit circle to do that. So notice if we construct a ray joining the origin 0, 0 to some point on the unit circle in the first quadrant, then for this angle theta between the positive x-axis and this ray, we have we can construct a right-angled triangle by dropping a perpendicular from this point to the x-axis. And notice that the hypotenuse here has length 1. So therefore, the x-coordinate of this point is x and y, and the x-coordinate is the length of the side adjacent to this angle. And we know that cosine of theta equals x over 1, and that's equal to x. So we have the first coordinate of this point is cosine of this angle theta, and similarly the height of this triangle is y, and the sine of theta is y over 1, which is y. So the second coordinate of this point is sine of theta. So now we extend the definition of cosine and sine to any angle by constructing the terminal side of the angle while it's in standard position, and we look at the point where that terminal side cuts the unit circle, and then the first coordinate of that point is cosine of theta, and the second coordinate is sine of theta. And we see this is compatible with the definition we gave before for angles between 0 and pi over 2. And the picture looks like this. For angles between 0 and pi over 2, we have the ray from the origin is entirely in the first quadrant, and in particular this point on the unit circle is in the first quadrant. And so you have the cosine is positive, the sine is positive, and the tangent is positive here. If the angle is between pi over 2 and pi, then the end of the ray, or the point where the ray cuts the unit circle, is in the second quadrant, and we see that the cosine is less than 0, sine is greater than 0, and tangent is sine over cosine, which is less than 0. So here we define tangent of theta to be equal to sine over cosine, and again that's compatible with how we defined tangent before. And we can also have angles between pi and 3 pi over 2 where the terminal ray is in the third quadrant, and also for angles between 3 pi over 2 and 2 pi, the terminal ray is in the fourth quadrant. And here's a summary of which of these trigonometric functions are positive and negative in each of the quadrants. In quadrant 1, we have cosine is positive, sine is positive, and tangent is positive. And in quadrant 2, we have the x value of any point is negative, so cosine is negative, y value is a positive, sine is positive, and tangent is now a plus over a minus, so that's negative. And for angles with terminal ray in the third quadrant, we have both the cosine and the sine are negative, because the x and y coordinates of points in this quadrant are negative, and tangent is a negative over a negative, so tangents are positive. And for angles with terminal rays in the fourth quadrant, we have Here x coordinates are positive, so cosine is positive. Y coordinates are negative, so sine is negative, and tangent is a minus over a plus, and so that's going to be negative. So using this definition of sine and cosine, we can find the tangent of some basic angles, and all of the angles on this list have terminal side either on the x or the y-axis. And so let's have a look at what's going on here. We'll draw a unit circle, maybe here, pencil in the x and the y-axis, and we have 4 points here where our circle meets the x and the y-axis. So it meets the positive x-axis at the point 1, 0, the positive y-axis at the point 0, 1, the negative y-axis at the point 0, negative 1, and the negative x-axis at the point negative 1, 0. And so let's think about sine, cosine, and theta of these angles. And in order to do that, we just need to figure out where the terminal angle is, or where the terminal ray is of the angle. So we're looking for sine theta, cosine theta, and tangent of theta of each of these angles. And note that by definition, sine, cosine, and tangent depend entirely on the position of the terminal ray of the angles. So coterminal angles have exactly the same sine, cosine, and tangent. What about the zero angle? Well, its terminal ray is along the positive x-axis, so that meets the unit circle at the point 1, 0. So cosine is 1, sine is 0, and tangent is sine over cosine, which is 0 over 1, which is 0. The angle pi over 2 has a terminal ray coinciding with the positive y-axis, which cuts the unit circle at the point 0, 1. So cosine of this angle is 0, sine of the angle is 1, and tangent is sine over cosine, which is 1 over 0, which does not exist. So in this case, tangent is not defined. And for the angle pi, its terminal ray is the negative x-axis, which cuts the unit circle at minus 1, 0. First coordinate, minus 1 is the cosine, 0 is the sine, and the tangent is sine over cosine, which is 0, over negative 1, which is 0. For the angle 3 pi over 2, its terminal ray is the negative y-axis, which cuts the unit circle at the point 0, negative 1. So its cosine is 0, sine is negative 1, and tangent, which is sine over cosine, does not exist. It just simply isn't defined in this case. The angle 2 pi is coterminal with the angle 0, so its sine, cosine, and tangent are exactly the same as the sine, cosine, and tangent of 0. The angle minus pi over 2 is coterminal with the angle 3 pi over 2, so it has the same sine, cosine, and tangent as that of 3 pi over 2. And the angle 5 pi over 2 does a full revolution plus another revolution, another quarter revolution, and it's coterminal with the angle pi over 2. And so therefore it has exactly the same sine, cosine, and tangent.